Opens in 2018, Crossrail will connect 28 existing stations to the West End, the City and Canary Wharf through 21 kilometres of new twin-bore tunnels under central London. 8 tunnel boring machines, or TBMs, will drive through the ground to create Crossrail's tunnels. A TBM is 148 metres long and weighs 1,000 tonnes. This is the equivalent of 14 London buses end to end and a staggering 143 buses in weight. It has a rotating cutter head at the front and a series of trailers behind housing all the mechanical and electrical equipment. There are 2 types of TBM being used by Crossrail: earth pressure balanced TBMs and mix shield TBMs. 6 earth pressure balanced machines will be used for the 18 kilometres of tunnel through the clay to the west and the riverbed deposits in the east, while 2 mixed shield machines will be used to drive the tunnels through the chalk beneath the River Thames. Depending on the geology below and the buildings above ground, each TBM will travel between 90 and 150 metres each week, ending up to within a millimetre of where it needs to be. The first part of the TBM's work is the tunnelling phase. The earth pressure balanced TBM has a cutting wheel which is pressed against the tunnel face by hydraulic cylinders. Inside the cutting wheel, the disc cutters and scraping tool loosen the material. If the earth is unstable, and to stop the tunnel face collapsing or digging too fast, the TBM uses the soil that has already been dug out by the cutting wheel to support the tunnel face. This creates a stable environment for the tunnelling to move forward. The tunnel face is continuously monitored by pressure sensors. They check the turning power of the cutting wheel and the screw conveyor, and they also keep track of the material that's been excavated. The material is then taken away on conveyor belts. Once the tunnelling phase is done, the cutting wheel and screw conveyor are stopped and the ring building phase starts. A complete tunnel ring consists of several lining segments made of pre-built reinforced concrete. These are made in a special factory above ground. They must match the exact size required and are taken into the tunnel on flatbed rail cars. The concrete segments are fed in by the segment feeder and lifted into place using a vacuum. The hydraulic cylinders are temporarily retracted in order to provide enough space for the new segment. The segments are positioned with millimetre precision and held in place by cylinders before being finally bolted into position. The conical keystone is put in from the front to complete the lining ring. Each individual tunnel ring is built in a slightly conical form. This means that curves can be built along the tunnel route by changing the direction of the cone. The hydraulic cylinders are extended again to secure the segment into position. During all this work, the people and machines are protected by the shield skin from the saturated ground where water is under pressure. All the readings are displayed on monitors in the central control cabin and fed back to the machine operator. Once each section of ring building is completed, the next tunnelling phase can start. The mixed shield TBMs dig in a different way to the earth pressure balanced TBM and will be used for tunnelling in waterlogged conditions such as below the Thames. Mixed shield TBMs use bentonite, which is a slurry of clay and water, to support the excavation face and act as a suspension medium for excavated material. The excavation chamber is behind the cutting wheel and separated by a submerged wall from the working chamber. The excavation is completely filled with bentonite and the working chamber is approximately 2/3 filled. The 2 chambers are connected in the form of communicating pipes via an opening in the submerged wall. A filter cake is created ahead of the cutting wheel by pressurizing the bentonite in the working chamber with compressed air. The bentonite penetrates the ground to form a membrane which holds back water. Changes in the soil can be handled by adjusting the pressurization. The dug-out material falls into the excavation chamber. Small grains are dissolved into the bentonite and bigger stones and debris fall to the bottom. Flushing nozzles guarantee smooth removal of the excavated material. The excavated material is pumped through the suction line to the separation plane at the surface. Here, the soil is separated out and removed from the bentonite suspension through a centrifuge, and the clean suspension is transferred back into the slurry circuit. As tunnelling advances, the flexible extension lines are installed to extend the lines after each thrust phase. Crossrail's first pair of TBMs, Phyllis and Ada, will construct Drive X, travelling from Royal Oak to Farringdon. A second pair of TBMs, Elizabeth and Victoria, will construct Drive Y, starting from Limo in Docklands and heading under central London to Farringdon. A further 2 TBMs, Mary and Sophia, will construct the tunnels for Drive H, running underneath the Thames from Plumstead to North Woolwich, followed by Drive Z and Drive G. All the tunnels will be completed by the end of 2014, a significant milestone in the programme to build the largest addition to the South East rail network in 50 years.